In this lesson, we're going to go over solving linear equations. So our objectives are to understand equations, to solve for the unknown, usually x, in a linear equation, and learn how to check your answer so that you always know if you got it correct or not. So equations. Equations have an equal sign, and what that equal sign means is that the left-hand side must equal the right-hand side. We see this in other ways. For instance, 60 minutes is equal to 1 hour. So if I were to tell you this meeting ends in 1 hour, you could say, okay, this meeting ends in 60 minutes, and it means the same thing. Or Summer Olympics are going on right now. So if we talk about the GOAT in gymnastics, that's talking about Simone Biles. So you could use either term in that context to denote Simone Biles or the GOAT in gymnastics. Okay, so with that, the right-hand side must equal to the left-hand side, which is where it comes in. What you do to one side, you must do to the other when solving an equation, something you've probably heard before or may have heard before, and that's because you have to preserve what's happening with that equal sign. So the goal with an equation is to find the value or values of the variable, whatever variable you're given, that make the equation true. So what that means is if an equation is true, it means we have like 7 equals 7. Okay, it does not mean 3 equals 4. That's not true. Okay, so when we're solving an equation, there's 3 different options. An equation can have one unique solution, it could have no solution at all, or it could have infinitely many all real numbers, also denoted by negative infinity to infinity. Okay, so let's get started. So without using your paper and pencil, no calculator, anything like that, take a look at these 3 and just think, what value of x makes the given equation true? Meaning, what value of x would make the right-hand side equal to the left-hand side? In the first example, x equals 7, x has to be 7 because 7 is equal to 7. Okay, so in this case, the answer is x is 7. In part B, x plus 7 equals 30. That means what number added to 7 is equal to 30? You might think 23. 30 equals 30, that's true, so x is 23. Okay, and for the last one, part C, a number minus 6 is equal to 12. That number must be 12, and it's not because the right-hand side is 12, it's because that's the value of x that makes the equation true. Okay, so thinking about these, you may know what the answer is right away. We're going to go over some steps to solving a linear equation. Again, I cannot emphasize enough that our goal is to find the value of the variable that makes the equation true. So when solving linear equations, I recommend getting rid of parentheses first, so distributing, combining your like terms on each side, getting your variables to one side and your numbers to the other, so that way you can see the value of x that makes the equation true, and then check your work. There's usually an easy way to check to see if your answer is true, kind of like we did on the previous slide, for you to know if you made any mistakes, to see that you're getting the answer correct, and things like that. Okay. So example number 1. Oh, I don't know why it started off with, the previous one was number 1. Okay, example 2. Solve for x and simplify your answer, and then we're also going to check our answer. So when we're looking at this, we have negative 6 minus some number equals 10. You may know this by looking at it, but if we're going to solve, we don't have any parentheses, we don't have any like terms to combine on either side. So we start off by, we need to move the 6 over to the other side. That 6 is negative, so we add it, okay? And I'm very careful about my work here. This equal sign kind of divides our equation in half. So you have one side, the left-hand side, and the other, the right-hand side. Negative 6 plus 6 is 0. And then we bring down negative x, okay? There's still a minus sign in front of the x that has to come down. 10 plus 6 is 16. So we're left with negative x is equal to 16. Okay, you can think of the negative in front like a negative 1. So we divide both sides by negative 1 because negative 1 divided by negative 1 is just x, which is our goal. 16 divided by negative 1 is negative 16. Okay, so when we check our answer, we take the answer we got, negative 16, and plug it back in for every x in the original problem. So what that looks like is we have negative 6 minus, okay, and then I'm going to put negative 16 equals 10. So the writing in black is part of the original, and the writing in green is the answer we found. I usually put a question mark above my equal sign when I'm checking my answer. Okay, so negative, negative, so this is negative 6 minus a negative, which becomes positive. So 10 equals 10, that's true. Remember, 10 is not your answer. 10 equals 10. Just make sure that the answer you got makes the equation true. So the answer is x is negative 16. Okay, I have a spot on each of these slides for you to check your answer. On some of them, I'll start with the setup, but I may not go through each of them for the sake of time. But if you do have any questions about checking your solution, please make sure you reach out to me. Okay, example 3, solve for x, simplify your answer. Okay, so we have no parentheses, no like terms to combine. So we move the 6 to the other side with the number. So I'm going to add 6 to both sides. And notice here, I'm just doing one thing at a time. So working on the left-hand side, the 9x comes down. We didn't do anything to it. Negative 6 plus 6 is 0. Our equal sign comes down, and then we have 57 plus 6, which is 63. Okay, so now we're at the point 9 times what number is 63? You may see that as x equals 7. Or what you can do is, since the 9 is being multiplied by x, divide both signs by 9 to also get x equals 7. This one checks very similar to the first problem, so I'm not going to go through the process of checking it. Okay. Next, solve for x and simplify. In this equation, we have numbers and variables on both sides of the equation. So you can decide what side you want your variables on and what side you want your numbers on. I recommend starting with moving one or the other, maybe not both at the same time, depending on your comfort level. Okay, so I'm going to start by moving the 52 to the other side. So that's the only thing I'm going to do right now. So that means the 7x comes down. Positive 52 minus 52 is 0. My equal sign comes down. 2x comes down, and then negative 13 minus 52 is negative 65. Okay. Now I'm going to move my x to the other side. It's a positive 2x on the right, so I'm going to subtract 2x from both sides. Okay. And again, because that equal sign is there, what you add or subtract to one side, you have to do to the other side. Okay, so 7x minus 2x is 5x. My equal sign comes down. 2x minus 2x cancels, and then my negative 65 comes down. Okay, so this is 5 times what number is negative 65, or divide both sides by 5 like on the last problem, and we get x is negative 13. Okay, I'll show you the setup for checking your answer for this one. Remember, we said that whatever answer you get, you have to plug into every x in the original. Okay, so this is 7 times negative 13 plus 52 equals 2 times negative 13 minus 13. Okay, and I'll leave that one for you to check. Solve for x and simplify your answer. So there's different ways that you can approach solving an equation. You can start moving variables from one side to the other right away. What I like to do is I like to condense each side or simplify each side as much as possible. So when you're working on the same side of an equation, you're combining like terms. Okay, the signs are changing when you start to move things from one side to the other. Okay, so for instance, I'm going to draw the line down the middle again. So if I have 5x minus 1 plus 9x on one side, the 5x and 9x can combine to 14x minus 1. Okay, so notice I didn't change any signs there. I just combined the like terms. Same thing on the right-hand side. 2x minus 4x is negative 2x plus 4. Again, this became a negative 2x because I combined like terms. Now I'm going to start moving my numbers to one side and my variables to the other. So I'm going to start by adding 2x, and now the sign change happens because I want to get rid of the negative 2x on the right, and in order to do that, I have to add 2x to both sides, gets rid of it on the right, puts it on the left-hand side appropriately. So this is 16x minus 1 is equal to 4. Okay, so then I get my numbers to one side, so I'm going to add 1 to both sides. And I'm going to go over here. I'm going to rewrite this. Okay, and so here, 16 times what is equal to 5. This is a case where maybe it's easier to divide by the number in front of x to get x is equal to 5 over 16. This one might be easier to check in your calculator. Okay. Number 6, so we have parentheses. So in order to see what you have on both sides of the equation, I recommend getting rid of the parentheses, which in this case means distributing. Okay, so we have 2 times x minus 1, so the 2 gets multiplied to the x and the negative 1. And same thing on the right-hand side. You can think of that as a negative 1 on the outside when you see the minus, and we're going to distribute it to both terms inside the parentheses. Okay, so on the On the left-hand side, we have 2 times x, which is 2x. 2 times -1 is -2. Equal sign comes down. 8 comes down. -1 times x is -x. -1 times 1 is -1. Okay, so from here, you can combine like terms. I know on the right-hand side, we have 8 and -1. So this would look like 2x minus 2 is equal to 7 minus x. And then this follows the same way that we've done the previous problems. Okay, so I'm going to add x to both sides. We have 3x minus 2 is equal to 7. Okay. And then we are going to add 2 to both sides. So we're looking at 3 times what number is equal to 9? 3 times 3 is 9, so that gives x is 3. Again, that's because the value of x needs to be 3 in order for 3 times 3 to be 9. Okay, I'll set up the check on this one as well. Since we have parentheses, just be careful that x needs to go in, or the value you found, 3, needs to go in for every x that you see in the original equation. So this is 2 times, we have 3 minus 1 equals 8 minus 1 times 3 plus 1. Oops, I should have done that in a different color. Okay, so you'll plug it in everywhere you see x, and I'll leave it for you to check. We'll continue on solving linear equations with some fractions, and we'll see our different solution types in the next lesson.